A smartphone sells under one name, wrapped in one logo, presented as one seamless product designed by one company. That's the story on the box. It's almost entirely fiction, not because the company lied, but because no single company, no matter how large, actually makes a modern smartphone by itself. To understand what making a smartphone really means, you have to follow one imaginary device backward, piece by piece, through a network of companies and countries. Most of its eventual owners will never think about. Start before the phone is a phone at all, before it's even a component. With raw materials pulled out of the ground in a handful of specific places on Earth, the rare earth elements used in tiny magnets and vibration motors, the lithium and cobalt that eventually become part of the battery, the high-purity silicon that every chip on the device is built from. These materials aren't evenly distributed around the world. Specific deposits, specific refining capabilities, and specific processing expertise are concentrated in a small number of countries and often a small number of specialized companies within those countries. None of this is glamorous. Nobody puts a mining operation in a product launch video. But without it, nothing downstream exists at all, and a disruption at this earliest stage, a mine closing, an export restriction, a refining bottleneck, can quietly ripple all the way to a delayed product launch months later, long before anyone assembling the phone even notices something upstream went wrong. That concentration of raw material sourcing carries its own kind of risk that rarely gets attention until something goes wrong, when the deposits, refining capacity, or processing expertise for a critical material sit heavily concentrated in one country or one region, that region's political relationships, export policies, and even its weather can end up shaping a smartphone's cost and availability on the other side of the planet, months before assembly even begins. A trade restriction on one specific material, an environmental regulation that shuts down one refining facility, or even a temporary export slowdown tied to unrelated political tension between two countries can ripple forward through every later stage of the chain, arriving at the assembly line as a shortage nobody there actually caused. Phone brands increasingly try to diversify where they source these materials from, qualifying multiple suppliers across multiple countries for the same input, precisely because, depending on a single source anywhere, this early in the chain creates a vulnerability that no amount of good planning at the assembly stage can undo later. From there, those raw materials travel to a completely different set of specialized manufacturers who turn them into the actual visible and invisible parts of the phone. And this is where the story starts to split into distinct, largely independent tracks that only come together at the very end. Take the display first, because it's the part of the phone people look at more than anything else. Building a modern smartphone screen means manufacturing an extremely thin layer of light-emitting material sandwiched with touch-sensing circuitry and protective glass, all thin enough to bend slightly without breaking and precise enough to render millions of individually controlled points of light. This is its own entire industry, dominated by a small number of companies with the specialized factories capable of producing displays at this level of precision and at the volumes a global smartphone launch requires. The brand whose name appears on the finished phone typically doesn't manufacture this screen itself. It designs the specifications, the size, the resolution, the color accuracy it wants, and then works with one of these specialized display manufacturers to actually produce it, often negotiating years in advance to secure enough manufacturing capacity for a launch that hasn't even been announced yet. Then there's the processor, the chip that actually runs everything the phone does. This part of the chain splits again into pieces that rarely get discussed together. The underlying instruction set and often the core processor design may be licensed from a company that specializes purely in chip architecture rather than manufacturing anything physical at all. The actual chip layout, tailored to the specific phone's needs, is often designed in-house by the phone brand or by a specialized chip design partner. But the physical manufacturing of that chip, actually etching billions of transistors onto a silicon wafer, happens at dedicated semiconductor fabrication plants, facilities so capital-intensive and technically demanding that only a handful exist in the entire world capable of producing chips at the smallest, most advanced sizes flagship. Phones require. A single phone's processor might therefore represent licensed architecture from one company, design work from a second, and physical manufacturing from a third. Before it's even a finished chip ready to be placed on a circuit board, memory tells a similar story with its own specialized track. The chips that store the phone's data and the separate chips that give the processor fast-working memory come from an even smaller, even more specialized set of manufacturers. Some of the same companies whose memory technology also feeds the AI data centers on the other side of the tech industry entirely. Demand from one part of the electronics world can quietly squeeze supply available for smartphones, and a shortage or price spike in memory manufacturing, driven by a completely unrelated boom in some other product category, can raise costs or create delays for smartphone production without a single decision being made by anyone actually building phones. Cameras add yet another layer of specialization because a modern smartphone camera isn't really one part. It's a small system in itself, combining a precision image sensor, a stack of tiny curved lenses assembled with extraordinary tolerance for error, and dedicated processing circuitry that cleans up and enhances the image the moment it's captured. Each of those pieces tends to come from different specialized suppliers, some of whom compete fiercely with each other for placement in the next generation of flagship phones, since camera quality has become one of the most heavily marketed features on the entire device, even though almost none of it was actually built by the company whose logo appears on the back of the phone. The lens stack alone can involve multiple elements, shapes, ground, and coated with extreme precision, since even a tiny imperfection in curvature or coating can visibly distort an image, and image sensors are themselves manufactured using processes closely related to the same semiconductor fabrication techniques used for the main processor, just optimized for capturing light rather than executing instructions. Radio modules, the components that let a phone connect to cellular networks, Wi-Fi, Bluetooth, and satellite positioning, bring in yet another set of specialized suppliers because building components that reliably handle radio signals across dozens of different frequency bands used by carriers in different countries around the world is its own deeply specialized discipline, blending physics, regulatory compliance, and manufacturing precision that few companies outside of a small handful of specialists have any reason to master, by the time all of these separately manufactured pieces exist. A display from one specialized manufacturer, a processor drawing on licensed architecture and dedicated fabrication capacity, memory from another highly specialized supplier, a camera system built from several distinct component makers, and radio modules from yet another set of specialists. None of them are anywhere near each other. They're often manufactured in different countries entirely, each shipped toward a final assembly location according to a schedule planned months in advance, coordinated so that every component arrives at roughly the moment it's actually needed on the assembly line, rather than sitting in an expensive warehouse waiting. Assembly itself, the stage most people actually picture when they think of a phone being made, is often handled by yet another specialized company entirely. A contract manufacturer whose entire business is precision assembly at enormous scale, employing enormous workforces trained specifically to fit these components together with the speed and consistency a global product launch demands. The brand designs the phone. The brand markets the phone. The brand often doesn't operate the factory floor where the phone is actually assembled at all, instead contracting that responsibility out to a manufacturing specialist built for exactly this kind of large-scale precision work. That assembly process is far more demanding than simply snapping components together. Fitting a display, a battery, several camera modules, radio components, and a densely packed circuit board into a housing only millimeters thick, with almost no wasted internal space, requires assembly line precision closer to what you'd expect from scientific instrument manufacturing than from typical consumer electronics. Workers and increasingly automated equipment have to be trained and calibrated specifically for each new phone model. Since even small design changes between generations, a slightly repositioned camera, a redesigned battery shape can require retooling significant parts of the assembly process. Every finished unit passes through multiple layers of testing before it's allowed to leave the factory, checking everything from display responsiveness to radio signal performance to camera calibration. Because a defect discovered after a phone has already shipped to a customer costs vastly more to fix than one caught on the line. This is also why launching a brand new phone design is riskier and slower to scale up than producing another year of an already established model. The assembly process itself has to be learned and refined nearly from scratch each time, running in parallel with every other stage of the chain that's also trying to hit the same launch date. And once assembled, the finished phones still have to travel often by air freight for the initial launch window, when speed to market matters enormously, and increasingly by sea for the bulk of ongoing production, once the initial demand surge settles into a steadier pace. That logistics network is itself a specialized industry layered on top of everything else, involving customs regulations in every country the phone will be sold in, shipping capacity that has to be booked in advance, and warehousing timed precisely enough that phones arrive in stores neither too early, sitting in storage costing money, nor too late, missing the exact week a marketing campaign told the world to expect them. This logistics stage carries its own quiet fragility, separate from anything that happened earlier in the chain. Air freight capacity has to be reserved months ahead of a launch, competing with countless other industries shipping their own goods during the same peak season. Ocean freight, cheaper but far slower, has to be scheduled around port congestion, customs processing times that vary enormously from country to country, and import regulations that can change with little warning. A single port closure, a shipping route disruption, or a customs policy change can leave finished, fully working phones sitting in a container somewhere, unable to reach the store shelves they were built for, even though every single component inside them performed exactly as designed. The phone can be perfect and still arrive late, because the very last stage of this entire chain depends on infrastructure the phone company doesn't own or directly control any more than it controls the mine that produced its raw materials in the first place. Underneath all of this physical movement of materials and components sits a separate, less visible network that's just as tangled: intellectual property. A modern smartphone doesn't just contain physically manufactured parts, it contains thousands of licensed patents covering everything from how a radio module encodes a signal to how a touchscreen distinguishes between an intentional tap and an accidental brush of a finger. Some of these patents belong to the same specialized component suppliers already providing physical parts. Others belong to companies that don't manufacture anything at all having built their entire business around researching and licensing a particular technology used industry-wide, a single phone, before it can legally be sold in a given country, typically requires licensing agreements covering wireless standards, display technology, audio compression, camera processing techniques, and dozens of other narrow innovations, each negotiated separately, each adding cost, and each representing one more party with some claim over what's inside the device sold under someone else's name entirely. Walk back through all of this, and the central question posed at the start starts to answer itself. Can one company actually control the production of its own smartphone? In the sense of designing it, specifying every requirement, and putting its name on the final result? Yes, completely, in the sense of physically manufacturing more than a small fraction of what's inside that device. Almost never, not even for the largest, most powerful technology companies on the planet. What these companies actually control is the specification, the integration, and the brand experience wrapped around the product, built from the accumulated specialized expertise of dozens of other companies, each mastering one narrow piece of an enormously complicated puzzle. This is exactly why a smartphone's launch date can be threatened by something that sounds almost absurdly small: a shortage of one particular capacitor, a delay in one specific component from one specific supplier. A natural disaster disrupting one factory that makes one narrow part almost nobody outside the industry has ever heard of. The finished product looks unified and seamless, specifically because the company assembling it has spent enormous effort hiding just how distributed and fragile the underlying network actually is. Every visible feature on a launch keynote slide, display quality, camera performance, processing speed, represents a separate negotiation, a separate manufacturing relationship, and a separate point where something could have gone wrong, long before the phone ever reached an assembly line. That fragility isn't a flaw unique to one brand or one product. It's the structure of the entire modern electronics industry, built this way because no single company, regardless of its size or resources, can simultaneously be the best in the world at chip architecture, display manufacturing, camera engineering, radio design, precision assembly, and global logistics all at once. Specialization at this level produces components far more advanced than any single company could realistically build in-house from scratch. But it also means the finished product depends entirely on dozens of independent points of coordination, all working correctly, all at the same time, for a device that ends up small enough to fit in a pocket and simple enough that using it never reveals any of this complexity at all. It also explains why the companies at the top of this chain spend so much effort on relationships. Most customers never hear about securing manufacturing capacity years in advance, sometimes helping finance a supplier's factory expansion just to guarantee first access to whatever that factory produces, or deliberately qualifying a second and third supplier for the same critical part purely as insurance against exactly the kind of disruption described throughout this chain. None of that shows up in a keynote presentation. All of it is arguably as important to whether a phone ships on time as anything shown on stage. So the next time a new phone launches with a single logo, a single price, and a single keynote presentation, remember what's actually sitting underneath that unified presentation: a raw material pulled from a mine somewhere on Earth, refined by one company, shaped into a chip by another, paired with a display built by a third, a camera system from a fourth, radio hardware from a fifth, assembled by a sixth, licensed through patents belonging to still more companies again, and delivered by a logistics network involving yet another layer of specialists, an entire planet's worth of coordinated expertise, compressed into something you can hold in one hand and never think twice about.